How discoveries in science come from challenging orthodox thinking. How speed of innovation is being enabled and threatened by the information revolution. This year's Nobel Laureates debate the issues on Nobel Minds with me, Nik Gowing. Australians Robin Warren and Barry Marshall are the medicine laureates. This is inside someone's intestine, and this is an ulcer, easily detected these days by this tube camera, an endoscope. For many years, the medical profession used to assume that people, maybe people like me, get ulcers because of stress and anxiety, too much emotional pressure. Doctors Marshall and Warren turned that conventional wisdom on its head. Against all the assumed odds, they showed that ulcers like this are caused by bacteria, infection, and once sampled by these biopsy forceps can be eliminated by antibiotics. To remove an ulcer, therefore, expensive surgery is now replaced by just a week of drugs. Roy Glauber and John Hall, both from the United States, along with Theodor Hänsch from Germany, are the winners of the 2005 Nobel Prize for Physics. Roy Glauber's theoretical work on the nature of light was followed up by the others' use of lasers to measure that light with extreme precision. Richard Schrock and Robert Grubbs from the United States are two of this year's 3 chemistry Nobel laureates. They all worked on a process known as metathesis, that's the changing of places. They revealed how carbon atoms, just like dancers, change partners to form new compounds. In economics, Robert Aumann from Israel and Tom Schelling from the United States are recognized for their work on game theory and incentives. It's pretty impossible to depict this on television, so both laureates will give us a taste of their distinguished work in a few minutes. Well, welcome to you all around this Nobel Minds table. Let's get a sense of the kind of challenges you've all had in producing the distinction that's recognized here. Let me go to Robin Warren and Barry Marshall first with that extraordinary way that you challenged orthodoxy on discovering what causes ulcers. Robin, you started the work. How much were you really taking on, if you like, the establishment in the medical field?
Well, I'm a pathologist, and working down in the laboratory, I soon found you're a little bit separated from the clinical world, actually, sitting in the laboratory. And I was taking on the entire medical profession, actually, because of that. I saw these bacteria one day in a routine biopsy. That,
just show us, I mean, this is 10,000 times bigger than the real thing.
They actually looked like that. I saw a typical case of fairly severe active gastritis in my laboratory, just the routine reporting I did, and I thought I saw some bacteria sitting on the surface of the epithelium. And a few days later I got electron microscopy of that, and it showed quite clearly bacteria, just like this one, sitting on the surface of the epithelium. And that's where it started.
So what was your instinct? You've described how you were kind of the heretics on the fringe of this world. How much did you say, I've got to now prove that what I know is correct?
Well, that really started because my colleagues tried to convince me that it wasn't of any importance. The whole thing about that was, of course, that at the time, everybody thought bacteria didn't grow in the stomach, and what I was looking at was something that wasn't supposed to be there.
So how did you take it forward? Here we were in the early 80s.
Well, this was 79, but yeah. I took it forward by looking for more of them. I was challenged to find some more, or shut up, So,
you were really told, just stop it.
Well, find some more, that's what they actually challenged me to do.
Prove it, in other words.
Yeah, prove it.
So how did you link up then with Barry? Why did you link up with Barry?
Because a couple of years later, Barry came into my room and wanted to see what I was doing. And, by that time, I'd collected a whole series of these. And he was looking for a project to work on, and I was looking for a clinical helper because I wanted to get, a bit of a leg in the clinical world to get some decent biopsies and to spread out a bit.
So Barry, did you realise that in joining Robin you were taking on the medical establishment as well?
Well, it was a simple thing in the beginning that Robin had seen bacteria that were not supposed to be living in acid, because acids are supposed to kill bacteria. And so
And that's what there is inside a stomach?
Yeah,
inside
so I mean, it's like, you know, your stomach has got the acid in there to digest food and kills any of these cholera or any other organisms you might eat. So everybody thought that the stomach was like that glass of water, perfectly clear acid inside it. Nothing could live there. But of course, Robin pointed out that these little bugs were there, which we called Helicobacter. And then when we went to the patients to see why these people were sick, we found out that nearly everybody with an ulcer had the bacteria. And so we said, does the bacteria cause ulcers? Because if it does, that means instead of ulcers needing surgery and affecting your whole life and being caused by stress, etc., maybe they're just caused by bacteria irritating the lining of the stomach, and therefore you could cure them with antibiotics just in a couple of weeks instead of major surgery. So one of the problems, of course, there was a big industry already on treating ulcers with drugs and you know, hundreds of surgeons doing operations every day. I mean, it was a great life for some people.
And you were about to challenge it. You were about to fight it.
I mean, we were going to kill the industry. And we knew that early on, but we didn't let on. But that's why, although we were, you know, there were a lot of skeptics and saying, it's never going to happen, it's never going to happen. We were there like quietly, we're going to show you guys.
Now, you had even problems getting your research accepted for review.
When something's very, very new and it hasn't even been considered and there's no need for this kind of new idea, because everybody thought they already knew the cause of ulcers. So they weren't looking around, what's the cause of ulcers? We said, here's the cause of ulcers, and they said, we know that. We know the cause of ulcers, we don't need another one. So there was nobody who could look at our paper and say, yes, you know, that seems to be true or not true. They were completely in an information vacuum. And so we couldn't have our paper accepted for many months until someone in the UK actually had duplicated the work. And then they said, it must be true, we can do it here as well.
Did you feel completely shunned by the medical business and the medical profession?
There were times, I think, when we did feel that way.
Yeah, but did you feel you were taking a risk which was going to actually leave you to you being marginalised at some point?
Well, we were marginalised, no doubt about it, but we didn't have a big research empire that we had to keep going.
So you had no vested interest?
We had no vested interest in the old technology, and so it was really only upside as far as we were concerned. And if we were wrong, well, we would have just disappeared and gone off to do something else. Whereas for somebody else to say, you know, I'm the top gastroenterology professor in the United States and I agree with Marshall and Warren, I mean, he's putting his neck on the line as well, which nobody was game to do for about another 10 years.
Well, another 10 years. Now, what has been the impact on the medical profession in terms of, if you like, money saved? Operations are no longer done. You can now solve this with antibiotics in literally a week or two. Robin?
Well, I've had a lot of surgeons and old gastroenterologists come and actually thank me for changing things or telling me that, you know, I changed their world. But I mean, it hasn't taken anything away from them. They've just done something else.
Well, the drug business was $3 billion at least per annum. An equally large business was the ulcer surgery business, another $3 billion. And I'd say at least another $3 billion were people's lost days off work and just sheer aggravation. And one of the laureates here today has actually a story to tell about his own life being affected by an ulcer.
Let me introduce Tom. You have that problem, Tom Schelling. You're the laureate in economics, but your career was blighted at one point by the fact that you had ulcers and there was a particular diagnosis.
I was diagnosed as psychoneurotically permanently unfit for military service because under stress I would hemorrhage and become a casualty. If you had only done this 65 years ago, I might have had a military career.
And gotten killed.
And possibly gotten killed.
Well, but what do you think that impact would have been if you'd known that 65 years ago?
Not
if I'd been treated.
Not if I'd known that. If the Army, the Navy had both known it, then they could have known that with antibiotics, I could be made fit for military service. If an ulcer recurred, treat me again. But the idea was that I had neurological characteristics that meant that under stress, I would generate an ulcer. And they believed that that was the source of the ulcers. And they argued that during the great stock market crash of 1929, people with ulcers showed up all over the place because of the stress they were undergoing with the stock market crash.
Let me widen this a bit, Barry, because in one of your reports, you wrote, quote, a 32-year-old man, a light smoker, a social drinker, who had no known gastrointestinal disease or family history, swallowed the growth from a flourishing 3-day culture of the isolate. Now, the reason I'm saying that is, of course, you didn't identify yourself. How much ethically and morally could you get away with that now, these days, 20 years later?
I don't think you could. It would be the end of your medical career or
in other words, you didn't declare
career.
that you were researching on yourself.
No. We published it in the third person, but it was me drinking some bacteria. The reason I felt that I had to do it was I saw many people with duodenal ulcers who were bleeding or having their career affected, etc. And I felt that there was pressure on us to move the science forward and prove the bacteria could cause ulcers or cause stomach problems. And at that time, I was the only person in the world who was informed enough to make an informed consent to be a volunteer or guinea pig in that type of experiment. So if I'd asked an ethics committee for permission to do it, they might have said, no, you can't do it. And I would have said, well, what do you guys know? I'm going to do it anyway, and which could have caused a career problem. But these days, because of liability, insurance issues that hospitals have to worry about, they can't have investigators carrying on with their own human research, even on themselves. It's too risky. So I would have, nowadays you'd be immediately sacked if you did that kind of experiment.
And we've seen what happened in South Korea recently with the professor there who had done human cloning, who had used some of his own female researchers, and that was seen as unethical these days.
Yeah, people would argue about it, and I would say you should talk to the researchers who volunteered and see what they say. But the thing was that they fudged the documents a little bit, I believe.
Wasn't the yellow fever thing done exactly that way? A person gave himself yellow fever?
It wasn't done that way. He gave it to his colleagues, not himself.
To himself? No.
Yeah.
Even worse.
Dick Schrock, from the chemistry point of view, what's your view? I mean, we're trying to broaden this out in terms of the ethics of some of the experimentation and the kind of work that you've been doing. You have done work with Bob Grubbs about molecules and atoms, and you've got an example there. Just tell us what you've done, but then let's broaden it out into this ethical business and in the business of how you can do experimentation.
Well, what we've done is we've come up with a catalyst that explained a reaction that was nearly 50 years old. Now it's 50 years old. That takes a type of bond that's found in many organic molecules, a carbon-carbon double bond, and basically chops it in half. And we can demonstrate that. These are two propylene molecules. So this is a methyl group and a CH and a CH2. And these are very stable species. They'll never do anything really. Okay, you can burn them and so on, but they will not come apart. And what the catalyst that we have discovered does is it scrambles the ends. It does this sort of dance.
Which ends are you talking about?
One end with a methyl group on it and the other end with a CH2. And we just can take these double bonds apart like this and
so that's the changing partners, like
changing partners. Right. And now instead of a 3-carbon olefin, we have a 2-carbon double bond there, and he's making the 4-carbon double bond. This is called ethylene, that's called trans-2-butene.
Right. Now, what does that mean in simple language for those who don't understand the complexities of chemistry? This dancing partners moving around, and what products you end up with?
Okay, it doesn't happen normally. You need a catalyst.
Yeah, and the other thing is the properties of propylene is the 3-carbon piece is very different than the 2-carbon piece and the 4-carbon piece. And it also works if you put many other big groups on here. And then when you do the change, then you go from one molecule to another very different molecule. And for example, we were just discussing the knots here.
Well, we'll talk about the knot theory, the alternative knot theory in a moment. Right. But let's just stay on the chemistry.
And so the thing is, we can make molecules which have those kinds of structures, which have but by using the same chemistry.
Many different kinds of stuff.
That's right.
Complicated organic molecules, polymers, fancy pharmaceuticals. all containing double bonds of some sort, and the ability to chop them and scramble them is what we can do.
And in simple terms, please, John.
Let me ask what happens if there would be two double bond systems in the one molecule.
Well, they would each be involved in this reaction.
It breaks both.
In theory.
In theory, yeah, or else they can make cycles. I mean, for example, one of the products that's being made now is to take seed oils. These are oils that come from corn and soybeans, and everybody knows that they're unsaturated. That's the reason they're liquids.
That's what this means, unsaturated.
Unsaturation, carbon double bond. And so they're now taking vegetable oils and throwing one of our catalysts in, and it turns it into other products that can be used.
In simple terms, things like plastics. So you get a different kind of plastic which is not petroleum-based anymore.
Well, some of them they can be petroleum-based or not petroleum-based. And in that case, it's making a wax that's being used to make things.
So this is a significant shift.
Yeah, it can be a very significant shift. Yes.
But let me pick up from what Barry and Robin were talking about this challenge to orthodoxy, because you went through something similar.
A little bit, yes, because
it took 18 years.
The reaction wasn't known, and people didn't think we could ever make it work in very complicated cases. I didn't think that in the beginning, but as the chemistry developed, we became aware of the fact that we could make more and more complicated molecules. But we didn't have the real problem, because once we demonstrated that you could do this, the community adopted it very rapidly.
Well, you say very rapidly, but the kind of timescale you're talking about is many years, a decade or more.
A decade, but that's very rapid in the chemical community in terms of developing things.
We'll come on to that shortly.
That's right, yeah. I mean, it normally takes 10 to 15 to 20 years for things to go from beginning to end.
But do you recognize the problems that Robin and Barry went through in terms of changing orthodox minds?
Oh, yes, right, very much so.
It's a similar sort of process. I mean, they say, prove it. That's what scientists
do.
do.
That's right, yeah.
We say, we've discovered this, this is the structure, we think it's relevant to this reaction, and they say, well, prove it.
Prove it, yeah.
And then you go and try and prove it, and then you get to the next level, and then they say, well, prove that. It's a game that goes on until finally everybody says, okay.
Yeah. I have a question. If I had an oil refinery, and all of a sudden you were making things in a little back shed out of canola oil, it was the same thing. Would the guy with the oil refinery be trying to sponsor your research, or would it be his competitor that wanted to have the new technology that's going to help you?
That's who's supporting it now, are the people who are making the corn oils.
Did you realize when you were doing this the number of applications which would emerge?
Absolutely not. It was just, it started out just being a fascination with the reaction. And then once it's, and most of the things we do now I didn't think were possible when we started. And so as we've moved along, more and more things become possible, and that opens up more and more applications.
Now, I have to say, we've even made a discovery sitting around the table as we prepared for this discussion a few minutes ago, because I want to go now to Bob Aumann, who is one of the economics laureates. And Bob, can you just explain to us your alternate knot theory? Certainly. Now, many people won't understand this, but there is an important principle, and then we're going to join up and show that science is moving forward even around this table. Bob.
Yeah, well, the Nobel Committee...
just show us your knots there. Okay.
Here we are, yes. But let me just preface this. The Nobel Committee decided on the prize for me because of my study of long-term interaction between people and other entities. And here we have an interaction between pieces of rope.
Okay, yes, you've got 3 circles there of rope.
We have 3 circles of rope over here. And my thesis, my doctoral thesis, more than 50 years ago, was in knot theory. It was not at all in game theory. Game theory came after my doctoral thesis. And now what the thesis was about is this kind of knot, which is called an alternating knot. You see, it's made out of 3 pieces of rope. And if you take a look at the red rope, it goes over the gray one, and then under the blue one, and then again over, and then again under, and then again over. And all of these knots, all 3 of these pieces of rope are that way. And it won't come apart. If you try to pull it apart, there's no way that it'll come apart. Now, if you take this one, this is also a knot. It's made out of 2 pieces of rope, and they go under, the black one goes under the red one, and then it goes over the red one, and then over again. So it's not alternating. It doesn't alternate. It doesn't go over, under. And it does come apart, yes? It will come apart. So a part of my thesis was that alternating knots will not come apart. And you could say that there is a lesson to be learned from this, that if you want a knot, a relationship, the word for relationship in Hebrew is the same as that for knot, kesher. It's the same word, yes? And if you want a relationship to last, then sometimes one has to be on top and sometimes the other, yes? It's not going to work if always the same one is on top, or even for too long if the same one is on top.
And quickly,
so that is now, yeah. So the amazing thing is that what I thought was something totally useless, and that's what attracted me to it. This is something which is very easy to state, very easy to understand. It'll go on the Nobel Minds TV show. It's very easy. Anybody can understand this principle, but it's very, very difficult to prove. And I thought at the time, 50 years ago, that it's absolutely useless. Absolutely useless. And that's what made it attractive, because that's what attracts mathematicians. Now,
and how do you apply that to game theory in economics?
Now, 50 years later, to the day, yes? To the day, 50 years later, my grandson, Yaakov Rosen, who is in the second year of medical school, calls me up and he says, "Grandpa, can I pick your brains?" And I say, "Sure, Yaakov, what can I do for you?" He said, "We're learning knot theory in medical school." I said, "You're learning knot theory in medical school?" He said, "Yes, because sometimes the DNA gets knotted up, and that may cause problems like cancer and things like that. So we have to understand knot theory, and our professor is explaining it to us, and I don't understand what he's saying, and I don't think he understands either, and maybe you can explain it to me." So I was absolutely bowled over, because here was this pure science, absolutely pure, which attracted me because of its uselessness. And 50 years later, it's being taught in the second year of medical school. And now at this table, it turns out that they have synthesized this kind of molecule with these rings going in and out, and they have different chemical properties from this kind, which will not come apart. Yeah, maybe you want to say something.
So have we built a bridge
yet?
here between
Yes.
economics and
Yes.
chemistry?
We'll see. Well, yeah, at least the same principles, yes. Yeah.
Why does that apply to you in chemistry?
In chemistry, one likes to build interesting structures and see what they will do.
Yeah.
And so one of my colleagues at UCLA who I work with has been building knots and examining these kind of structures. And he recently created exactly this structure using atoms and molecules. Yeah. And so it's a molecule that we will see what the properties are.
Did he do it with metathesis?
That one he didn't do with metathesis.
Okay.
Others
But
he does.
some are done with
some are done with metathesis, yeah. Because it's a way
Sense
to
there
do
of
things.
really how science can converge on issues like this. Let me move to the physicist. Roy Glauber, you were involved in the Manhattan Project, building the bomb in the Second World War with Robert Oppenheimer, the distinguished nuclear scientists like Hans Bethe. You've been around a long time, but there's this issue of
It's a good thing.
there's this issue of challenging orthodoxy. For you as a physicist, what do you hear there which is very similar to what you've been through in physics?
Well, we have a bit of orthodoxy in physics as well. It's oftentimes a very well-established orthodoxy, and it's not easy to assail. I must say, you just made me think of a rather perverse case. Albert Einstein,
Who you knew?
found himself attacking an orthodoxy, and I'm afraid he was wrong. During the latter half of his life, he was very disturbed by the notion that things happen by chance in nature. in a truly mechanistic view of the world, and that was certainly his, nothing happens by chance.
Certainly in your world, in physics.
Well, a great many things do, I'm afraid, happen by chance in our world. And we've spent a long time coming to accommodate the thought.
But how easy is it for your peers to accept revolutionary thinking in physics?
Well, it's not easy, but occasionally we have to. I mean, there's a famous example. Einstein, in his criticisms of quantum mechanics, and he didn't let up until about 1935, came to the ultimate quantum mechanical paradox. It's known by the names of Einstein, Podolsky, and Rosen. And it is saying something that is so strange and so spooky, as he put it, that he simply refused to believe that the phenomenon would take place. It has been shown to take place. And one of the things that's being worked hardest on now in the development of quantum computation and quantum cryptography is precisely this. We have what you might call the EPR industry these days, the Einstein-Podolsky-Rosen industry, carrying out this sort of spooky entanglement, as it's called. It's mystifying, and I dare say I couldn't explain it to you in a few words. But there are these strange things that are part of nature.
Let me underline that, of course, your work with John and Ted Hänsch has been about creating very precise measurements. Ted, you've got in front of you a piece of jelly, nothing more than that. But explain to us how jelly helped you define light with great precision.
Yeah, I brought the jelly as a symbol for the importance of childlike curiosity and playfulness in research.
And has that underpinned all your research?
Yeah, in our discussion about challenging orthodoxy in 1970, there were some lasers, gas lasers, honed by John Hall and others, that were precision instruments with which you could do beautiful spectroscopy, but they were not tunable. They were limited to some narrow spectral lines of atoms and the gas discharge. And then a few years ago, dye lasers had been invented, organic dyes that you could dissolve in a liquid, and you could pump them with a flashlight or with a pulsed gas laser, and they would emit beams of light that could be tuned in color, but of miserable spectral quality. And people felt, well, this is chemistry, this is not precision laser physics. But playing with these dyes at Stanford, at one time Art Schorlow, my mentor, came and said, let's try and see if these jelly desserts that children like, if they couldn't be turned into a laser. So for a week or so, every morning, we mixed up 2 different flavors and colors of jelly dessert and held them under the nitrogen laser. And unfortunately, well, they showed bright fluorescence, but no laser beam came out. So Art Schorlow took this afterwards to his office and had it as a snack. But in the end, we didn't want to give up. We felt that known laser dye, sodium fluorescein, wasn't all that toxic, so we could afford to mix a little bit into a clear jelly, and that indeed then made a laser material that could be cut with a knife into laser rods, and we published a paper on what might well be the first edible laser material, and that attracted quite
how much have you and John been challenging orthodoxy here?
Ted is the usual one to find himself with newspaper people coming around because of this unexpected imagination. My interest has been to try to remove the uncertainty so people could know which exact frequency we're going to have. So we don't have much trouble until finally the standard that we've made is better than the existing standard. And then that brings some colleagues from another country and then another country. And after a few years, each has their own thing. And then we sit around a table like this with approximately 50 countries represented. And then each guy is thinking to himself, well, now am I going to be the one that goes home to my boss and said, oh, for the benefit of the whole world, we decided to go with his proposal for the laser wavelength standard. And you can see that that doesn't work so well. So you'll find another solution, which everyone can agree on, which is we won't have a wavelength standard. We'll, in fact, change the basis for the international system of weights and measures, and we'll drop out the meter. We'll make the meter a defined quantity. We'll take a number and say the speed of light is the following, 299,792,458 meters per second exactly. So that challenged orthodoxy and brings me letters from people who are not necessarily cranks, who are saying, oh, you've omitted a piece of physics. It may be that space transforms in a different way than time does. And in fact, some retired person such as myself actually has an experiment underway now to see if there, because we have now so many more digits, maybe it would be interesting to redo this experiment that has Michelson's name on it, or experiments from the 30s that carry Kennedy and Thorndike.
Roy.
I'd like to come back for a moment to Einstein, because I don't want to misrepresent as formidable a figure as Einstein. He spent most of his life as a revolutionary.
Do you need to be a revolutionary to qualify yourself almost to sit here and be selected by the Nobel Committee as having done something which has significantly shifted discovery and innovation forward?
Well, you can change the direction of things. I wouldn't call myself that much of a revolutionary, but Einstein was. And in his earlier years, starting in 1905, which we commemorate the centenary this year, he put forth the idea of the light quantum, and it was another 15 years before it was generally adopted. During that time, he was certainly pushing the idea of the light quantum, but at the same time gathering his doubts. And his doubts concerned the question of whether God, in effect, plays dice with the universe. And eventually, he became a different sort of revolutionary, a counter-revolutionary.
The people who have an investment in the current paradigm and not the people who want to change. And so that if you come up with something new, if everybody who has the investment in what's happening right now is interested in keeping that investment, and you're going to have to challenge it. So this is where the proof comes in. The person who's making $1 million a day on drug X is not going to say, on the basis of one experiment, okay, we're going to close down our factory and stop making money and go to drug Y. It's going to be the person who is the competitor of drug X. And so what we did with the single experiment, it was very interesting, everything, and it triggered all these competitors everywhere to look at the new possibility and try and generate data. So what you said is also correct.
Robin.
Actually, I think, the longer I've been living, the more I see of how actually I don't think there is, in human life, there is any such thing as absolute proof of anything. We just try and improve previous proofs, and sometimes they seem to change the way we look at things, but I don't think that we ever have an absolute proof. Newton was pretty good back in his day, and Einstein improved on it. I don't think he proved Newton was wrong.
Well, should I just test that here? Does everyone agree with that? No absolute proof, yes or no?
Certainly.
Yeah.
Yes.
We agree with him.
Everyone in agreement?
That's right. Yeah.
Okay, let me move on the issue of competition and cooperation, about how much competition between you, even between you, Dick and Bob, how much competition and cooperation are parallel or contradictory at times. How much competition has there been between you both? How much have you been revering each other to a certain extent? How much is cooperation in your developments crucial to making those seismic leaps, Rob?
Okay. Yeah, I think the cooperation through the literature is extremely important, of being sure you keep each other informed. I think friendly competition and ethical competition is extremely valuable in science.
Are you in competition with Dick?
On occasions we have been, yes.
Friendly competition or difficult competition?
Well, it's been competition where one tries to do it in a very ethical way.
Dick?
Yeah.
Are you in competition with
I mean, we published one paper together, but other than that, we've gone our separate pathways side by side, essentially competing, but in a constructive way.
Barry and Robin, are you in competition, or I mean, did you have a really complementary and cooperative relationship? You went to him and said, "I need your help."
No, he came to me and said he wanted my help.
No.
But you were looking for the clinical experience.
I came to Robin and said, "You need my help."
I had the finding, but I guess I needed someone like that. But Barry just turned up looking for something.
But the issue of cooperation is crucial, is
Actually, our cooperation, I think we cooperated extremely well, but we published quite a lot of stuff together, but we also did have our differences and fights. And I think the ball sort of bounces backwards and forwards, and if it didn't, it wouldn't be healthy.
Well, one thing I'd say is that you don't necessarily have an objective view of your own new ideas and your own interpretation on something. So it's very useful to have a colleague to bounce it off, and family members, you know, your partner, for instance, just so that you can perhaps hold back on some of the crazy ideas that you have and test them a little bit longer before you would go ahead and publish or get it out there. And it benefits us all, I think.
How much is mentoring important in all of this? After all, Ted and John, you relied very much on a couple of papers that Roy had written. How much was that mentor relationship crucial for you throwing forward your ideas, Ted?
I think to have some role model is important for young scientists, and for me, Art Schorler at Stanford played such a role, showing that it's all right to be childlike and playful, and also showing how one properly deals with one's students and co-workers. I mean, beyond that, of course, we all see each other. We see how other people work and how they are successful, and we try to learn from that.
John?
I agree that one expresses his admiration by picking up some of this "let's have fun today in the lab" style from Ted, and to some extent the high technical things, because there were no tools for making stable lasers, so there was a lot of learning in wrong directions, and I have a nice storage of dead avenues that will have to be disposed of pretty soon.
Right.
One picks up more. It's not exactly an apprenticeship one serves, but there's a great deal that brushes off from the people you've worked with. It's not always science. There were Oppenheimer students who developed the same dry cough. I've seen one student of Julian Schwinger develop his identical handwriting. There's a great deal of identification that goes on.
But here, 55 years on after you were with Oppenheimer and Hans Bethe and so on, do you still think in their way?
I try to.
And you're conscious even now, is at the age of 80?
I sometimes see the image of these very people in my mind, yes.
How does that relate to you both, Bob and Dick, in terms of this mentoring? Did you have a mentor, Dick?
Well, mentor implies that a person who guides you over a long period, I would say, at least that's my view. In my case, that wasn't true, but there was a person who had an idea, and I was attracted to that idea, to that area, and that person started, basically, my investigation. So it depends how you define mentor. If that's acceptable, then I did have a mentor. I got started because of some interesting new type of alkyl compound, a transition metal species. I made one that was very similar, and that began my saga.
There's really a close relationship between mentoring and this issue of cooperation and competition. Because I think cooperation and competition are really complementary. Competition sharpens it sharpens your wits. It makes things clearer.
Let's pick up on that issue. Bob Grubbs, you mentioned from a chemist's point of view that 10 years is a short time in your business. Right. But information technology is changing all our lives. what's becoming the impact on science and research and exchanging information and knowing that it's good information and not hokey information?
Okay, yes. So it's been very positive in the chemistry area because we have a well-established tradition of peer review.
Which means?
Papers being reviewed by other scientists and being able to present them with enough information so they can be sure you're right and the information is reproducible. So as long as that's maintained, it's been extremely useful because one can now find information so much faster. In the old days, you'd spend hours in the library trying to find information and tracking it down. Now you go online and in seconds you have it right at your desktop.
But how good is that information? How sure are you that what you're reading is good science and not hokey science?
It's exactly the same science that I read in the library, in the journals. So it's basically the peer-reviewed information from the journals that you can get.
It's making the past journals infinitely more accessible.
Oh, yes, right, yeah. You can
but
find
it is doing something else.
Yeah.
There are these archives that are collecting unpublished papers.
Okay, yeah, those can be
and
difficult.
they are not reviewed.
Those are not reviewed.
They
Those
are
are
simply
difficult.
put online immediately.
Right.
And that is growing at an explosive
Right,
rate.
yes, right.
Are you comfortable with that?
Well, there it's let the buyer beware.
That's right, yes, right.
Anybody
have to
can
do,
put
yes, right.
anything
Yeah.
on the internet in these archives.
Right.
Well, that's what I'm asking, Dick. I mean, is there hokey science, I keep using that phrase, hokey science emerging, which is untestable, or is it actually promoting and creating a multiplier effect when it comes to your science, for example?
I don't know if there is hokey science. I am certainly suspicious. I mean, if this becomes the standard way of publishing science, it's unacceptable. And you have to be very, very suspicious of what is said because perhaps it's not reproducible, perhaps it wasn't even done the way they say. We have no way of knowing, right?
And in brief, I don't look in the archives unless someone says, oh, there's a paper here which is provocative. And
I rely on publications in peer-reviewed journals.
You still want a hard copy, that bit of paper?
No, not necessarily.
No.
But I have to have the confidence that what I am reading has been peer-reviewed, and I know that it's as correct as one could make it.
Well, I do look on the archives, and it's absolutely necessary in the theoretical area. I would not rely on that sort of source for experimental work, which might indeed be wrong.
Ted?
My perception certainly has changed a lot. I remember that maybe 5 years ago, I would feel a publication is only real if it's in the library, if it's in a bound volume, and this electronic information is sort of fleeting. But now I have the opposite feeling. I say, if it's just on paper, well, that can burn. Yeah. If it's on the internet, anybody in Africa or in China has access to it. Right.
And now they have ASAP and previews and so on. And on the very day that this paper, authentic paper appears, students come in and say, hey, look at this. I just found it, right? Because they are aware every day.
I'd make a
Those
comment.
are still real papers.
The general public has got an upside-down opinion of the peer review process because to a layperson, a published book has got a lot more credibility than scientific papers. They say, well, if you wrote a book about it, you must be the expert. But in fact, books are the least authoritative. Anybody can write a book. And what we're talking about is a scientifically reviewed and published paper to us is the gold standard. But I just warn again to the lay public, if it's in a book, be highly suspicious of it, including my book.
But given that you spent years trying to get your work reviewed, what would have happened, do you think, 20 years ago, if you had posted your research as a 32-year-old man, a light smoker and social drinker out on the net? Do you think it would have been picked up much quicker and believed?
I think it would have. I don't know. No, I don't think it would have been believed.
But it wouldn't have been peer-reviewed,
But there might have been 100,000 people discussing it. Rather than 1,000.
Immediately.
Yeah, and then there would be a chat room and a blog, and I'd start up my website and everybody can discuss it. And there might then be some consensus. And actually there is a live encyclopedia on the web, which I don't study very much. I think it's called Wikipedia or something. Yes, and I've actually seen the entry for Helicobacter, and if Robin and I had spent a month writing it, we couldn't actually do any better. People have gone in and edited it and fine-tuned it. And
but would that have been good for your science, do you think? if it had happened 20 years ago?
Yeah, I think it would have saved thousands of lives.
Oh, we're so busy praising the peer review system. Let's not forget that it has a few problems. The problems of competition, for example. The first thing an editor does is to send your paper to the most obvious competitor. And sometimes it's to his mind, absolutely unacceptable that your paper
In other words,
be published.
orthodoxy.
It's not necessarily orthodoxy. That is plain old competition. Unfair competition.
In other words, doing down a competitor.
Right.
Oh, yes, right. Yes,
And it's particularly important when one of the persons is more senior and established and has a laboratory full of stuff. Then the young guy's paper is sent to him, and then two papers appear simultaneously. Now, a lot of times that happens because good ideas are being propagated at the same time.
Peer review is not necessarily a question of unfair competition. It could be that the person who is reviewing the paper actually thinks this paper is garbage, yes?
I'd say it's a temporary technical issue because the search engines and everything are getting more sophisticated, and they'll answer this information overload for you very shortly.
I don't think so.
I think it's an experiment. Itself is an experiment, and we are waiting to see what the results will be, but it'll take some time.
Well, societies are helping this by having some journals that are in the middle. They're peer-reviewed, but in a week. And then it's online, and I can look at that. And sometimes
Are you comfortable with that 1 week peer review?
Oh, it works gorgeous. And we have 1 or 2 papers from my group in that way, and just a few days after the paper appears there, then someone calls up and says, oh, that was really cool.
Robin and Barry, after all, you live in Western Australia. That's where you've done all your work. That's where you are still. You haven't gone to America. You're still there in the Pacific region. Do you see that the information technology is enabling and giving greater prominence now to non-American areas of research? You've been through the German excellence before World War II. Now there's the American side. What about what's moving into your area with China, with India as well? Rapid economic growth. Are we going to see, do you think, incredible scientific growth, which will actually mean that around this table there'll be Chinese laureates in a few years' time?
I think there probably will be, actually, but just their population size and the almost exponential growth in their own education. And they're very industrious people, the Chinese. They've had their own civilizations. And civilizations come and go, and I don't know how ours is going, but I suspect that ours is probably reaching a peak, and theirs is on the way up again.
Barry?
I think the lead time is so quick, and as far as I'm concerned, I'm in my office with the door shut. It could be a lab in Beijing that's on the other end of that, the other side of that door, or Stanford. And the globalization of the whole thing is being connected up with the internet. We were saying, which country got the most laureates, and it's getting to the stage where it's not really relevant to me which country the research was done in, because we all own it as soon as it's out there on the net, and it's an interesting question.
I have no doubt we're going to see lots of Chinese around this table in the years ahead, but I think they will have come from America's Chinatowns.
And gone back home. But will they have gone back
to
home?
America? No, I don't think, after a while they will come from China without a doubt. But America is generating these people right now. My old high school is full of them.
Bob Grubbs, you have connections with the Shanghai Institute for Organic Chemistry.
Right.
What do you see changing there on your visits to China?
Just incredible rate of change. 5 years ago, there was no internet connections. The journals, there were journals, and they were massively used. Now they're all on the internet. They're from the journals. The facilities were awful. Now they've got world-class facilities. They're bringing back people from the U.S. to be professors, and so the whole situation is changing, and I'm frightened.
Are you excited as well, though?
I'm excited. Yeah, I'm really great to see it happen, and I'm glad it's happening there. And so you talk about competition. It's going to increase the competition for us.
But why are you frightened?
Well, for the competition.
You're jealous, in other words.
Oh, I'm jealous, and then frightened about how fast we're going to have to, and how hard we're going to have to work to keep up.
And is part of your fear that actually they will do fantastic science and fantastic breakthroughs in the way that it's taking you 30 or 40 years? Literally 10 or 15.
It's not that. It's just frightening in terms of the kinds of competition which we're going to have.
But that's good for you, isn't it?
It's very good for us, yeah.
Well, I went to the US, and I felt that the US system is incredibly generous. They don't care where you came from. If you're doing the top work, you'll end up being faculty, tenured, professor, making money, everything. And so that's one of the things. It's a scientific freedom, meritocracy, I guess, what you would call it. And in other countries at the moment, I don't think they have got a system that's quite as good. I think in China and a lot of developing countries, there's still a lot of mysterious people tweaking the system so that if you're the best, you're not necessarily the one that's going to float to the top.
But surely with information technology, they're able to share in very quick time the work that all of you are doing.
That's true. That's true.
I think the thing to be frightened about is somebody in your own discipline. It does not frighten me that the Chinese may do the kind of work that you have done. If we can cure my ulcer, I don't care who discovers it. So that I would say I'm bound to want all the competition there can be in physics, chemistry, physiology, medicine, and all that, because it can't help but benefit me and most of my fellow Americans. If I were to worry about competition, it would be that all of a sudden there are very smart economists or game theorists or somebody, and I'm old enough that they aren't likely to do me any harm, but I can see worrying about competition in your own field, but I can't see how an American scientist couldn't be pleased at the notion that as the Chinese come along, or the Indians, or the Brazilians, or whoever it's going to be, we may get more and more progress in all kinds of fields, whether it's developing new forms of laser or new understandings of disease. So my feeling is that we can only benefit if the Chinese become productive scholars and scientists.
And what's so marvelous now is that at home, the Chinese government is making an effort to catch back the ones who have always stayed here. So for the first time now, I have had a top-notch young person, and against advice of me and some others, he has taken a position as a researcher in one of their principal institutes.
Yeah, and I think that's partly because not just in the fields of science, but the living style of people in China is going to make it more and more attractive for people to go back to their home country. 50 years ago, countries like, say, South Korea or even the Soviet Union had to make sure that when people went abroad for study, they came back. Yep. And very often the technique they used to bring them back was to make sure that their families couldn't go with them. The families were essentially hostage. Now it's becoming attractive enough for a Chinese to go back to China that the government doesn't have to impose that kind of restraint on them.
Well, they're raising salaries to be competitive with what they would get in the U.S.
and providing labs that are on the same scale.
Well, I think, Bob, you said the labs are even better than the ones you've got now.
That's right now, yes. Yeah, they're doing very well.
I visited the NIH, and I kind of
What's the NIH?
National Institutes of Health in the US, and I mean that place was built in the 60s, as far as I can tell. There's great technology there, but I'm claustrophobic. I find that it's a bathroom with 5 foreign postdocs in, as far as I can tell.
Ted, here in Europe, do you feel in Germany the cold wind, the chill wind, or the warm wind coming from the developing world, like China, India, enormous excellence there, developing at fantastically high speed?
I think it's a very positive development. In basic science, we all benefit from discoveries regardless of where they're made. I think what people are more worried about is that sooner or later also the most innovative ideas for products will come from somewhere else. And industries in China will dominate our industries. And then, of course, our economy might suffer difficulties.
But it's a different issue. But I think we're in one world. I'm not worried about Chinese competition any more than I'm worried about competition from my neighbor next door in Jerusalem. Yes, let the best man go ahead, and it's one world, and I'm not. And there's some excellent game theorists in China and Japan. There's a lot of interest over there, and I say God bless them.
But finally, all of you, does this narrowing world with information technology and the way things are moving so fast in other developing parts of the world, does it keep you on edge now with all your work that you're doing?
I'm putting ads in the Chinese newspapers for postdocs.
Same with you.
Well, I mean, one has to, yeah, it's moving so fast, one has to keep working hard to keep up.
And Ted?
Yeah.
Yeah, I think there are exciting times ahead, and probably our imagination isn't enough to give us a sense what changes we will face, just say within the next 5 years. I think.
Or even 5 months or 5 days. Thank you all very much indeed, Nobel laureates, for joining us here on Nobel Minds. We've much enjoyed the discussion and underlined just how fast things are changing in all these disciplines, particularly with the information revolution and what's happening in the developing world. From all of us here at Nobel Minds and from me, Nik Gowing, in the King's Library in Stockholm, goodbye.